Hey guys, we're going to pick up with the Pythagorean Theorem. So this is Pythagorean Theorem day 2. So let's quickly review. We have our right triangle here. Remember that the side across from the right angle is called the hypotenuse. The other two sides are called the legs, but more commonly we use A, B's, and C's. A and B are your legs, and C always has to be the hypotenuse. So we use this formula, a squared plus b squared equals c squared, to figure out one of the missing side lengths of a right triangle. Now remember, C is always the hypotenuse, and this can only be done with right triangles. So we did 1, 2, and 3 together yesterday, but we are going to take a look at 4 and 5 on that same note sheet. So 1, 2, and 3, when we figured them out, we always had to figure out the hypotenuse. So that was nice and easy because the hypotenuse was always what we were looking for. When we do 4 and 5, they're going to be slightly different. So let's take a look at number 4. So let's first identify where the hypotenuse is in number 4. Across from the right angle is the hypotenuse. So in this case, the hypotenuse is not x, the hypotenuse is 14. So this is our hypotenuse, and this is going to be our c. That means that x and 7 are our legs, and those are going to go in for a and b. So let's write down Pythagorean theorem is a squared plus b squared equals c squared. For a, I'm going to put in x, one of the legs. So we have x squared plus 7 squared equals my hypotenuse, which is 14 squared. Now, if you run out of room or this isn't enough room for you, just grab another piece of paper and do your work on there. So x squared stays x squared. 7 squared, remember we can do that on our calculator, or we know that 7 times 7 is 49. Equals 14 squared. So 14 squared is 196. So here's where it gets a little bit different. Before we could just add these two numbers, but we can't add these two numbers. We have an x and we have a 49. So we want to get x by itself. So we have to bring the 49 to the other side. And the way we do that is, if it's adding, we do the opposite. So we're going to subtract 49. Subtract 49. So let's, on our calculators, do 196 minus 49, and we get 147. So x squared equals 147. So like we did before here, we want to know what x is. So we're going to take the square root. All right, the square root and the square cancel each other out. I'm going to write my work over here. So x will equal, and we're going to do the square root of 147, which is 12.1. So our leg is 12.1. And let's see if that makes sense. Is that less than the hypotenuse? It sure is. And that's good because the hypotenuse has to be the longest side. All right, so let's take a look at number 5. 5 is very similar to number 4. First, identify where the hypotenuse is. It's across from the right angle. 10 is our hypotenuse, our c value. So this is going to be at the end of a squared plus b squared equals c squared. 6 and x are the legs. So let's write down Pythagorean theorem, a squared plus b squared equals c squared. A little bit more room here. Let's put the 6 in for a. So 6 squared plus, let's put the x in for b. X squared equals our hypotenuse. We know that's 10, so we have 10 squared. So on our calculators or in our brains, 6 squared is 36. Plus x squared equals 10 squared, which is 100. Just like over here, we want to get x by itself, so I have to bring the 36 to the other side. So we're going to subtract the 36 cancel out. X squared equals 100 minus 36 is 64. I want to find out what x is, so I have to take the square root. The square root and the square cancel each other out. X equals, so the square root of 64 you might know in your head. If you don't, the square root of 64 is 8, because 8 times 8 is 64. Okay, so that's a nice short video today because we're still just going to practice the rest of Pythagorean Theorem. So you'll have some examples like this in your homework, and you'll have some examples from what we did the other day in our homework.